Welcome back to the Scotti-BYTE channel, and this is Scott. So in previous videos, I've had discussions about manipulating disk drives and partitions, and usually those apply to performing operations in a ZFS storage pool, and sometimes it is creating a virtual disk. So today is going to be just a little bit different. And I want to remind you that Home Lab Infrastructure tools are a key way to solving problems, and in Linux there's always more than one solution. And so in December of 2024, I presented Custom RescueZilla Bootable USB, where I showed how to create a bootable RescueZilla disk with persistent storage. And in my particular case, what I was looking to do was to provide a way to add the iSCSI protocol to my RescueZilla disk so I could perform my RescueZilla backups to iSCSI targets. And that worked out really well. And so image files, and normally they're .imgs, but they come in other types of formats as well, are pre-installed appliances, like when I went over the Home Assistant OS installation in an Incus virtual machine just a couple of weeks ago on June the 17th. And Incus virtual machines can help in converting and processing disk images that you can use for other purposes. RescueZilla is an awesome open source tool that you can use to make images of entire disk drives. And it's a GitHub project, and I've used it frequently to back up my systems. So in the video that I did here back in the end of 2024, I presented the RescueZilla with a little bit of an alternative, and that was to create RescueZilla with a persistent data partition, knowing that the original disk that you download is normally an ISO file. And you'll notice here that back from that video, well, I guess we should do a ls-alh to make things a little bit clearer, human readable form, and you'll see that the ISO file is 1.4 gigabytes. However, my disk image that I created with the persistent storage ended up being 15 gigabytes, and one of the reasons for that is because I created a fairly large persistent storage space. So I'm going to use some tools that are actually built into Incus to make that image smaller, thus making the persistent storage section of it smaller. Since I decided to work with my existing image file, you'll notice that it's 15 gigabytes, and I want to make sure that I have enough free space in my Incus default storage pool. And I'll check that by doing a sudo zpool list. And here you can see that I have a very large storage pool, and hardly any of it is used. For this project, we're going to need a couple of dependencies. So I'm going to start out by doing an Incus version, and I'm running the latest version, which is 6.14. So if you've been following my channel and you've installed Incus with the Incus container step-by-step video, that's a good thing. If you installed your Incus from the Ubuntu repository, then what we're going to do is not going to work. So the next thing we want to do is install some dependencies, and I already have those on this system. I believe they're going to be all of the QEMU dependencies, and so I'll have that in the show notes. When I did the Home Assistant OS and Incus 101 video 2 weeks ago, one of the important things we had was an additional dependency, and that is sudo apt install incus-extra. Incus-extra is where you would be getting the Incus-migrate tool. If you did an install of a sudo apt install Incus-migrate, then you would have the canonical version of Incus-migrate, and that coming from their repositories doesn't have the same options. So now, since we installed Incus-extra, I can do a sudo incus-migrate. And the first question we have here is the local Incus server is the target. We say yes. And then we're going to say we want to create a custom volume, which is option number 4. The name of the pool that we're going to create that volume in is the default pool. The name of the new custom volume is going to be my volume. And then the path to the particular disk image is going to be rescuezilla-bootable.img, which is in the folder where I'm running the routine. And then the next thing it does here is it says, would you like to go ahead and continue? And it provides everything else there. And I can go ahead and say, yes, go ahead and continue. Now that my raw volume has been imported, I'll go ahead and do an Incus storage volume list default my volume, and there it is. It is a block-oriented volume. Next, I'm going to create myself a virtual machine with Incus init. That's different from Incus launch because an init creates the virtual machine but does not start it. And we say images Ubuntu 2404, and we're selecting the desktop variant. We have --VM to indicate it's a virtual machine, and then the name of the container is going to be test. Ubuntu 2404 requires a minimum of 4 gigabytes of memory and 2 virtual CPUs, so I have specified those here as well. Now that the virtual machine has been created, I'm going to go ahead and do an Incus config device add test my volume, and this is of type disk in the default pool, and the source is my volume. What that does is that takes our custom volume named my volume and it attaches it to our new virtual machine. As a reminder, if we do an ls-alh, the original volume for the RescueZilla bootable image was 15 gigabytes. And we want to go ahead and make that image a little bit smaller, and that's one of the things we're going to do in this particular video. So I'm going to create a second volume, and that second volume is going to be called my volume-shrunk, and we're going to make it 5 gigabytes in size. And finally, we're going to go ahead and add that volume and connect it to that virtual machine with an Incus config device add test my volume-shrunk. It's a disk. It comes from the default pool, and the source is my volume-shrunk. Let's go ahead and boot up our virtual machine with an Incus start. And in this case, I move back to my desktop and I'm doing an Incus start mondo :test -- console equals VGA. And that will go ahead and boot up that virtual machine. I'll go ahead and go full screen on that here as we watch it start up. Now that the VM started, I'll go ahead and click next and click skip and then click next again and go ahead and click finish. So the first thing I'm going to do here is I'm going to go ahead and create myself a terminal with a Control-Alt-T, and I'm going to do a sudo add user Scott, and I'll go ahead and give Scott a password, and then I'll go ahead and do a user mod or a sudo user mod -a capital G sudo Scott, putting Scott into the sudo group. Now that I've done that, I'm going to go ahead and log off of here by clicking the power button up here and saying log out. When I do a log out, it will return back here and give me the option to log on to the Scott account, and I'll go ahead and type in my password and log into this account. Now that I'm logged into the Scott account, I'll go ahead and do a next. I'll go ahead and do a skip, And no, I don't want to share any system data. I'll go ahead and do a next and a finish. Next, I will go ahead and fire up a terminal, and in this terminal, I'm going to do a sudo del user Ubuntu, which is the default user it creates when we get a virtual machine in Incus. And now all I have here is the Scott account. From here, I'm going to go over and select dark style because I prefer it. Let's go ahead and enlarge this terminal by clicking on the menu up here. And I'll go ahead and hit the plus sign a couple of times. And we should have a big enough terminal now. We'll go ahead and drag this thing over. And the first thing I want to do is I want to do an LSBLK. An LSBLK is going to show us our boot device. SDA1 is the EFI boot partition, and SDA2 is the root partition for this particular system disk. By default, when you create an Incus virtual machine, it gives you a 10 gigabyte disk that we can override and make larger if we want to. But in this particular case, we're not going to do that because this virtual machine is just going to be used for utility purposes. SDB is our Clonezilla disk that we imported as an Incus custom volume and attached to this virtual machine. It has a device SDB1 and a device SDB2. And finally, our shrunk volume, which is a 5 gigabyte volume, is SDC, but it has not yet been initialized. Let's go ahead and install the gparted tool with the sudo apt install gparted. And at the same time, I'm also going to install another tool called part clone that can clone partitions. And I'll do a -y on the end, and both of those should go ahead and install. Just to make our job a little bit easier of resizing this disk, I'm going to go ahead and click on the app drawer, and then I'll go ahead and click on gparted. Type in my sudo password, and then gparted will come up and launch. Now in gparted here, we have the SDA device, which is the system disk, with the EFI boot partition and the root disk. We have attached two more disks to the system, SDB and SDC. SDB is when we imported the Clonezilla image into the default storage pool, and that's the one that you see here. So SDB1 is the main data partition for RescueZilla, and SDB2 is the Linux persistence partition. So I'm going to go ahead and click on the SDB2 here, right-click on it, and say resize and move. And then I'm going to go ahead and drag this considerably smaller. I don't know if you can see here or not, but it is showing the yellow space as the use space, and I'm leaving just a little bit left over. And I'll go ahead and say resize move, and then I'll go ahead and check off the apply all operations and click on apply. And now it is resizing the partition. Now that the partition has been resized, you'll notice that there is unallocated space on this. If we simply made a copy of this disk image, it would include that unallocated space. And so we're going to head back to our terminal to fix that. Just as a reminder, we'll do an LSBLK once again, and SDB that has SDB1 and SDB2 are the two partitions we want to copy to the new drive named SDBC. So we're going to begin by creating a GUID partition table on SDC with this command sudo parted /dev/SDC and we'll do that MK labeled GPT out there. The second thing we're going to do is we're going to create a partition, which is going to be SDB or SDC1 ultimately, and that's a FAT32 partition because that's what we have on SDB1. And the magic of live video looks like it does not like my specification of main data partition as a comment out there. So we'll go ahead and do an sudo parted /dev /SDB and do a print, and that is the original drive, and it looks like that particular drive is set up correctly there. So given that, let's go ahead and create ourselves a FAT32 partition mimicking that FAT32 partition with a sudo parted /dev /SDC and see if this works. And that went ahead and accepted it. The second thing we're going to do is create SDB or SDC2, and that should be created that way. Now if we go back up and go ahead and look at the printed partition table for SDC, it looks like we have a FAT32 and we have an ext3 there, which is what we wanted. So now we use our part clone program to copy the partition from SDB1 to SDC1. And that went ahead and completed, and it says cloned successfully. And now after we do that, we're going to clone the persistence partition, which is ext3, with the sudo partclone.ext3, and that's going from SDB2 to SDC2, and that was cloned successfully. Just as a point of reference, let's go ahead and open our app drawer and go back to gparted once again. Type in my sudo password, and this time let's go ahead and look at SDB or SDC. Notice that SDB was 14 gigabytes and change. SDC is only 5 gigabytes. So we click on SDB or SDC, and there you go. We've got 2.21 gigabytes, and it does have some spare space on there, and that looks like it should work just fine. I'm going to exit the gparted program, and I'm going to shut down our virtual machine by going up here and saying power off the virtual machine. Now that the virtual machine has been shut down, I'm going to go ahead and do an Incus config device remove test my volume -shrunk. Remember, when performing commands in your home lab, that context is everything. So in this particular case, I said remove from test, and I really meant to go remove from Mondo :test, as I did above when we started the console. And so now it says that that volume has been removed from test. Now I'm going to go ahead and add that volume back into test, but this time I'm going to go ahead and call it rescue disk since it's RescueZilla, but I'm adding a boot.priority equals to 10, which means that this disk will have a higher priority than the virtual machine disk will. And now if we start our virtual machine back up again with an Incus start Mondo :test --console equals VGA, it will go ahead and boot the virtual machine back up again, but this time it will launch RescueZilla from our newly resized disk. And I'll go ahead and tell it to start RescueZilla. Now the interesting thing about this configuration of my RescueZilla, since it has persistent data on it, if I go to do a backup of something, it will go ahead and recognize all of my iSCSI disks on my network here, and there is Incus My Volume there, as well as the Incus Rescue disk, and there are all of my iSCSI disks located elsewhere on the network. Since I want to operate directly in files, I move back over here to my Mondo device on the network, and I'm doing an Incus config device remove test rescue disk. And what that does is it goes ahead and removes rescue disk from test. To list all of the volumes in the default storage pool on this Incus server, I can do an Incus storage volume list default, and here you can see my volume and my volume shrunk. My volume shrunk is not used by a container right now because we just detached it here with this Incus config device remove command. What if I want to get a copy of this newly resized volume out of the Incus storage pool? The first thing I'm going to have to do is a sudo ZFS get volume mode out of the default storage pool custom default underbar my volume dash shrunk, and it says that the volume mode property is volume mode. And so the next thing that we want to do is we want to set that mode over to development, and we do that with the sudo ZFS set volume mode equals development. If we call that first command back again, it will tell you that instead of the value being none, the value is now development mode. And so we did that to give it visibility on the disk. And we can see where that file is by doing an ls-l of /dev/zvol default custom and the name of that particular volume. And so now, in order to make a copy of that back out here on my disk, I can go ahead and do a sudo dd, which is the disk duplicator, or some people refer to it as the disk destroyer, and the input file is going to be that same location we found up here, and the output file I'm going to make rescuezilla-shrunk-img. And when I hit enter, it will go ahead and begin writing out that file, and it is completed. Now if I do an ls-alh, I have a rescuezilla-shrunk image. You'll notice our original image was 15 gigabytes in size. Our new image is 5 gigabytes in size. One of the advantages of doing this is that here you're looking at my virtual media inside of my Jet KVM, and I was able to load the RescueZilla shrunk image that we just created over to the Jet KVM, and now I can boot from it. The storage on the device is somewhat limited, that is the storage on the Jet KVM, so that's the reason why I couldn't have a 15 gigabyte file, but I was able to shrink it down to a 5 gigabyte file that would work. Since I copied my image file out of the storage pool, I should go back and do a sudo ZFS set volume mode equals to none, and now when I go back and do the sudo ZFS get volume mode on it, you'll notice that it is out of development mode and back in this mode none. Since we're really finished with having created our volume, we're going to go back here and do an Incus storage volume list default. And at this point, we can go ahead and delete these volumes. And you can't delete a volume while you have a virtual machine associated with it, but you can unattach a volume and then delete it. But in this particular case, I'll just take a shortcut by doing an Incus stop on test. I think it's already stopped. If we do an Incus list, we'll see that it is in fact stopped. And then I can do an Incus delete on test, and that will go ahead and delete the virtual machine. Now if we go back and do an Incus storage volume list default, you're not going to see the volume for the virtual machine because the virtual machine is gone, and we have these two block volumes we no longer need. And so we can delete the custom volumes with Incus storage volume delete default my volume shrunk, and we can delete the other volume by doing an Incus storage volume delete default my volume, and then we can go back and do an Incus storage volume list default, and none of the custom volumes are there. You might be wondering why we still have two images around, especially if we do an Incus list and we see we have no containers. The answer to that is that when I created an Incus container at one point in time, it downloaded the image for that container in order to create it, and that was the file system image. And then when I created the virtual machine, it downloaded an image for it, and that is a block-oriented image. You can delete these images at any time after a container is created. The only reason that they're left on the system is to make the creation of future containers faster without having to do a download. So in summary, rather than using Incus Migrate to create a virtual machine, this time we showed how to use Incus Migrate to import a disk image into an Incus custom volume. And then the disk image was attached to a virtual machine, and we used gparted to resize a partition on that disk image. And we attached a smaller block-oriented custom volume to that virtual machine as well. And then the part clone utility was used to copy the two partitions from the original custom volume over to the smaller disk. And then finally, the last step was exporting the custom volume from the Incus storage pool back outside of the Incus storage pool to the Incus server, where we could use it for other purposes, like perhaps writing it to a bootable USB. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit your notification bell, and we'll see you next time.